Let's talk about composite functions. What is a composite function? Or they're also called compound functions. I know the first time I heard compound function, I thought compound fracture or 2 breaks in my leg. Not what we're talking about today, and not as scary as that. So let's jump right into what composite means. Composite just means to join 2 or more things together. So if we're talking about a composite function, we want to talk about joining 2 or more functions together. All right, well, what is a function? Let's just use an analogy of a function being an oven, and that the x's are the ingredients to the oven. So we want to stick ingredients into our oven, and we want to get out a finished product, which we'll call our y's. So the domain of our x's, the function is f of x, or it's our oven, and the finished product are our y values. So a composite function is more like a double oven. So we have to think about using 2 ovens at one time, or 2 ovens separately. Let's get a definition for what a composite function is. So let's have 2 functions. Let's let one function be called f of x and one function be called g of x. We'll talk about them as one being the outside function and one of them being the inside function. So if we let g of x be our inside function, it's going to be the beginning oven. And we're going to use some input and output values for x's and y's to figure out what works with g, and then use those with f of x as well. So if we think about a double oven, let's think about how you make sourdough bread in a restaurant. So the chefs or the people that are cooking are taking the ingredients for sourdough bread, and they need to be able to get the dough to rise and get its shape very quickly. So what they do is they take those ingredients, which we'll call them our x values, and they put them into the first oven. This oven is the first function. It's our inside function. It's g of x. And we're going to let that oven cause our yeast to rise and to get its shape. Then we're going to take that yeast or that dough out of that oven. So that's now our finished product. So it's a y value. Well, this y value is now going to become the x value for our next oven. So our input gave us an output. We have this dough. We're now going to stick it into a separate oven, which is going to cook the dough to become our bread. When we take it out, we have a finished product of the bread that we're going to use at the restaurant. So a composite function is a double oven system. It's an input, output, input, output. If we're going to use a mathematical definition for this, we'll say let g of x be a function whose y values become the x values for the f of x function. Let's look at notation for a composite function. So a composite function is written f of g of x. It has a little bitty circle between f and the g. It looks like the word fog sometimes. So we're looking at this little circle that's telling us to actually do the composite. It's read f of g of x. I teach my students to rewrite this to look a little bit more like something we're used to seeing. So if we write f of g of x, we now see that the g of x function is now the inside function. So we can label this as the inside function, and then our f of x would be the outside function. So we're going to use a double oven system. All right, so if we want to actually do an example with a composite function, let's use a real world application. We go shopping a lot. We love to buy food. All right, we want to go to the grocery store and we want to get some candy. So we know that the type of candy we want costs $2 a bag. All right, so we know we want to go in and we want to figure out how much money do I need in order to buy the candy that I want to buy. So I've set up 2 functions, and let's take a look at them. F of x is 1.07x and g of x is equal to 2x. And they're telling us to find f of g of x. So basically what we're going to find, a super oven is what we're going to find. We're going to find the oven within the oven. So if I rewrite this to look like f of g of x, all right, then how does that pertain to the real world application? All right, well, the inside function, 2x, is actually a function that will find out the amount of money I'm going to spend on my candy. So let's say that every bag is worth $2. So when we're actually looking at this 2 in the problem, we're looking at a dollar amount, where x is the actual number of bags of candy that we're going to buy. All right, so if we want to figure out the total amount of money, well, it's not just good enough to multiply my number of bags of candy times 2, because I'm probably going to have to pay some sales tax. So I've used the other function f of x to be 1.07x. The 0.07x is a decimal that could be written as a percent. So 0.07 as a percent is 7%. So I'm using 1.07 because I'm going to pay for the full price of the candy plus the additional 7% sales tax. All right, so if I want to create a super oven out of these 2 functions, I'm going to take the g of x function and I'm going to substitute it into the f of x function. So we're going to take the 2x function, our inside function, and we're going to substitute it into the outside function. So now I have the 1.07 times the g of x function, which is 2x. So if I multiply 1.07 times 2x, I get the function 2.14x. So what does this tell me in terms of the problem? It tells me that I'm going to pay $2 per bag, all right, plus the additional sales tax for each bag that I buy. So this would be considered the composite function f of g of x. All right, so let's say that we actually want to purchase the bags of candy and we want to see the exact dollar amount that we're going to pay. So let's use the exact same two functions, f of x and g of x, and this time we're going to find f of g of 3. So this time what 3 stands for is 3 is actually the number of bags of candy that I want to buy. So I'm going to rewrite the function in terms of 3. So we're going to have f of g of 3. So I'm going to substitute the value of 3 into the g function. All right, so I'm going to take 3 and I'm going to substitute it into the x value, which stood for my number of bags of candy. So I'm going to have f of g of 3. So if the 3 goes into the g function, we now have f of 2 times 3. And this gives us 6. So we have f of 6. So if we're thinking about this in terms of common sense, we know that if we buy 3 bags of candy for $2 each, we're going to be paying $6. Okay? So we're making it look like what it would look like as a function. Now let's take those $6 that we know we're going to spend and let's figure out how much more it's going to be for sales tax. So then I can take this amount of 6 and I can substitute it into the f function, which was my sales tax function. So if 6 takes the place of the x values in the f of x function, I have 1.07 times 6, which gives me $6.42. So in closing, what is a composite function? A composite function is really a function within a function. So it's a double oven system, to use our analogy. So really what we're doing is the composite function is allowing us to do 2 problems at one time to get one finished final product.